Hi guys, so today we're going to go over vectors. You have seen vectors before, they're just a line with a direction to it. So in geometry, you saw it as a ray. If you took physics, you applied vectors as forces. So today we're just going to go over the different ways to write a vector. So linear combination form, notice the example I gave you, 2i minus 3j, that's already written in linear combination form. And the I notates where on the x-axis or what the x value of that vector is, whereas the j represents the y value of that vector. So this has to be notated because technically adding and subtracting, you could put negative 3j first and plus 2y, so it's not what comes first or second. The I just tells you that it's correlated to the x, and the j tells you that it's correlated with the y-axis. So just know that if they place it out of order, that's how you're going to tell. Now, I've already plotted the vector itself, so the x is 2, the y is negative 3. So the initial point is always at 0, 0, and the vector will go in the direction and stop at 2, negative 3. So that's how we draw the vector itself, just a line with a direction. Now to write it in component form, notice that these triangular brackets, they represent that it's a vector, because if I put parentheses, that just represents a point. So that's pretty much how you write it in component form. Now, the question itself is asking for the vector in trig form. So in order to find it in trig form, you would find the magnitude of the vector. So notice that the magnitude, I'm just going to backtrack a little bit. Vectors are, remember, just the terminal minus initial point. So we arrived at this value x2 minus x1 and y2 minus y1. Same deal here. So the magnitude is nothing more than the distance or the length of the formula. Now, I did go over in the other tutorial how to write it from component or how to write it in component form given 2 points. So I'm just kind of reiterating here that a magnitude is just the length of the vector. It comes from the distance formula. So since this first term came from x sub 2 minus x sub 1, I already have that value. So the magnitude, this is already given to me. This is 2. You're going to write down the squared. Again, the I and the j just notates the x and the y value of the vector. You're not actually going to use it to calculate. It's not a complex number. It just tells you the direction of something. So plus y2 minus y1 was already given to me. That's negative 3 squared. And make sure that if you plug this into the calculator, the negative 3 is in parentheses before you square it. This would give me 4 plus 9. So the magnitude or the length of that vector is going to be the square root of 13. So we already have v. Now we just need to find theta in order to write it in trig form. So when you're writing an angle in trig form, make sure that you know which quadrant you're in. So everything here, vectors, complex numbers, they all come from right triangle trigonometry, meaning I can create a right triangle from here. So the adjacent side correlates with the x, which is 2. The height of the triangle correlates with the y value, or the opposite side is negative 3. If the angle is always by the origin. So notice I have opposite and I have adjacent. So that's why the angle itself is always y over x. So that means to find the angle of this triangle here, I am going to just take y, which is negative 3, divided by 2. Or you could say opposite over adjacent as well. So negative 3 divided by 2. All right, make sure that your calculator is in degrees first. You have negative 3 divided by 2, which is negative 1.5. And you need to get theta by itself. So that means you need to get rid of the tangent. The way to get rid of tangent is to apply inverse tan. Whatever you do to one side, you do to the other. So if I inverse tan negative 1.5, I am going to get negative 56.31 degrees. Keep in mind that while this is true, you'll probably not see the angle written this way. So what does negative 56.31 degrees mean? Well, look at where your vector is. Your vector, I'm going to note in a different color, your vector is here. This is your vector. Remember, negative angles just means that from 0 degrees it's going downwards, which makes sense because that would be the vector right here. So if it's going downwards, but I want the positive angle, that means I'm going to add 360 degrees to it. Remember coterminal angles. So negative 56.31 degrees. If I add 360 to it, it is still the same angle, hence coterminal angles. It's just I'm going to have the positive value of it, which is most likely how you will see your answers. So if I add 360, theta will equal 303. I'm going to round here, I'm out of room, 0.7 degrees. So now I have everything I need to write this in trig form. So for the vector, I'm going to take the magnitude times the cosine of theta I plus the sine of theta j and plug in the values that I have. So the magnitude is square root of 13, cosine of 303.7 degrees I plus sine of 303.7 degrees j. And this is my answer. Oh, that's not good. We'll go this way instead. All right, guys, I hope this helps.